Today we are going to perform a practical which is on prismatic compass. So it is very important practical which is performed in the surveying. So as the name of practical is study of prismatic compass. So compass is nothing but the instrument which is used for measurement of bearings of different lines. So what is meant by the bearing of line? So whenever we have to measure the angle between any point which is present on ground with respect to the north direction, then that angle will be called as the bearing of that line. So for this one we are going to use prismatic compass. Now in compass surveying there are three types of compass. So first one is the prismatic compass, second one is the surveyor's compass, and third one is the trough compass. Now this prismatic compass and surveyor compass are generally used for measurement of angles which are present on the ground, and this trough compass is generally used in only the plane table surveying. So now today we are going to learn the measurement of bearings of sides of triangle or polygon. Now what happens whenever we have to plot this triangle onto the ground, then for this one it is necessary to measure the angles between the different lines. So for this purpose we are going to use this prismatic compass. So now I will explain you the detailed components of prismatic compass. So students, before going into detail with the component parts of a prismatic compass, we will learn some basic instruments which are used for linear measurements in this compass surveying. So when we have to deal with the linear measurements between 2 points, then we have to use the chain or tape. These are the instruments which are used. So in chains we are having the engineering chain, metric chains. These are the different types of chains. So now I have this engineering chain. So this engineering chain is having brass handle at its end. So this is the brass handle. You can see that brass handle is attached to the end of this engineering chain. Then we are having these different links which are provided in this engineering chain. So this one link is of 20 centimeter, and at a distance of 1 meter we are provided with this brass rings. So this brass ring indicates that we have finished the distance of 1 meter. So you can see easily here 1 meter distance is completed by providing this brass ring. In this 1 meter distance we are having 5 links. That 5 links, each link which is of 20 centimeter. So the distance of 100 centimeter is completed at this point. Also whenever we are having the distances such as 5 meter, 10 meter, then in that case the chains are provided with these types of tallies. So this tally is provided at a distance of 5 meter, and this tally is provided at a distance of 10 meter. The length of the chain is written on its brass handle. So on this brass handle you can see the length is written as 20 meter. The material of this chain is made such that it will not easily corrode. Now you can see that these are the different links which are provided in this chain. So if the chain is of 20 meter, then we can use it for the measurement of 20 meter distance. Now the second instrument which is used for linear measurement is nothing but the metal wired tape. So these tapes are made up in the leather material or the metal material. So depending upon the metal material which is used for manufacturing of this tape, we can define it by its name. So this tape is also have the markings on it. So in meters also it is marked there, also in feet it is marked there. So we can measure the distance by using any type of scale which is feasible for us. So you have to remember that whenever you have to measure the distance between 2 points, then you have to use this linear measurements. Now the next instrument which is used in this linear measurement is arrows. So these are the different arrows. So arrow is nothing but a metal which is made up of metal material. This arrow is provided with the circular ring for carrying, and it is having needle like shape at its bottom. So we can fix this arrow on the ground, so whenever we have to mark any specific distance. Now the next instrument which is used in this linear measurement is the pegs. So these are the wooden pegs which are also used for marking different stations onto the ground. So these are made up of wooden material. We have to fix these pegs onto the ground. So for fixing on the ground, it is provided with the needle like shape. So these are some basic instruments which is used in this surveying for linear measurements. Now we will move towards the compass. So as I have told you that we are having the three types of compass. So now I am having these two types of compass with me. So this one is the prismatic compass and this one is the trough compass. Now prismatic compass is used for the surveying between the angles for the triangle, polygon and major areas, and this trough compass is only used in the plane surveying. So because this is having the limitations, it is have only markings up to the 5 degree. So we have to use this trough compass into the plane surveying. So it is not useful for the traverse surveying. Also for traverse surveying, we have to use only the prismatic compass, or we can use the surveyor's compass. Now whenever we have to deal with the centering or marking of any station, then we have to use this plumb bob. This plumb bob is provided with the line and dory. So it is used for marking the center onto the ground. So students, after learning the basic instruments which are used in surveying, now we will learn in detail about the prismatic compass. So this is prismatic compass which is placed in this cover. So this compass is made up of metal material. So metal cover is provided on top of this compass. So I will explain you in detail all the components of this prismatic compass. So it is placed like this. So when you open this cover, then you have to open this sight van which is provided on this prismatic compass. Now we will start with this component. So now for this prismatic compass, this is the prism which is provided in this prismatic compass. So due to this, it is known as the prismatic compass. So you have to place it like this over the compass. This prism is provided with the reflective mirrors which are used for observing the readings whenever we are performing the practical on ground, whenever sunlight is there. So to avoid the reflections, we have to use this reflecting mirrors. This prism is provided with one cover at the bottom. You can see that. So before taking readings, you have to place this cover at side. This compass is provided with this object van. So this object van is provided with the mirror. Also the crosshair is there. So this crosshair is also known as the horsehair, which is used for bisecting the object for which we have to measure the reading. So suppose you are bisecting the ranging rod, then you have to take care that the ranging rod should be in line with this crosshair. So this van is known as the object van, and the van from which we are observing the readings is known as the sight van. So whenever your eye is there, then that will be your sight van, and this will be your object van. This object van is also provided with the mirror. So this mirror will be helpful for bisecting the objects also, and you can able to read the readings on this side of the eye vein also by using this reflecting mirror. At the bottom of this object van, we are having this pivot pin. So this pivot pin is useful for stopping the graduations of this ring. So this ring is not stable. It is fixed at one point and it is moving due to the inclinations, due to the local attraction. So whenever you bisect your object while observing the reading, you have to place your hand on this pivot pin and you have to place it, so you have to push it so that that's you can read the reading which is present on this graduated ring. This prismatic compass is provided with this glass cover. So this glass cover is provided. At the bottom of this glass cover, below this glass cover, you can see that graduated ring is there. So this needle is attached to the graduated ring. This needle is pointing towards north and south. As we know that whenever we are dealing with the compass, so compass always shows north direction and it always try to move towards the north direction. So you can see that we have the marking of north, then south, and then we have this graduated ring. So this graduated ring is marked with different readings from 0 degree to 360 degree. So this prismatic compass is marked with the graduated rings as I have told you earlier. Also you can see that this graduated ring is freely moving. Also this brake pin is provided here. So if you press this brake pin, then the movement of this graduated ring will be restricted. Now on this compass you can see the readings are marked from 0 to 360 degree, and which are written in opposite direction, means when you are using the prism then you can able to read this reading. At the north direction we have the marking of 180 degree, and at the south direction we have the marking of 0 degree. Now from 0 degree to 10 degree we have the 10 lines, so that's why we can say that the least count of prismatic compass is 30 minutes, because 1 degree is equal to 60 minutes and we have total large lines of 10 numbers and small lines of 10 numbers. So for 1 degree we have 2 lines, so one line is of 30 minutes. So that's why whenever you have asked or whenever you have to measure the reading, then the least reading which you can measure by using this prismatic compass is of 30 minutes. So you have to remember this thing, and the use of this braking pin is very important, because you can see that once I hold the braking pin, the graduated ring will be stopped, and when I will freely move this braking pin, then your graduated ring will be freely moving. So you have to take care of these things whenever you are observing the readings. And this graduated ring is fixed on this pivot. So this center point is known as the pivot.
We have seen different basic components of the prismatic compass. So now we will perform the practical on the field. So you can see that this prismatic compass is fixed on the tripod. So basic settings of this prismatic compass are nothing but only the centering. So where we are placing this prismatic compass, you have to mark the center point of this prismatic compass by using the plumb bob onto the ground. So you can see that I have fixed the 5 station points and I will measure the bearings of these different 5 lines. So this is our point A, point B, point C, point D and point E. So these are the 5 points for which we have to measure the bearings. So now we will fix this instrument at point A. So now we have fixed the instrument at point A. So I will just make sure that the center point of A will match with the center point of our instrument. So with the help of plumb bob, I have fixed this center point, and with the help of arrow, this center point is fixed on the ground. So this is our first step before starting the prismatic compass surveying. So by using the plumb bob and arrow, we have marked the center. After marking the center, our next point will be to bisect the object at point B. So we will bisect this object, we will bisect the point B, and I will just measure the reading and we will note down the reading. So our reading is for point B, our reading is 71 degree and 30 minutes. So this is our first reading. Now what I will do, I will just bisect the point E, and for point E we will just observe the reading. So this is my point E, I have bisected the point E, and my reading for point E is, so before reading the reading you have to press the knob. So my reading for point E is 210 degree. So I will just note down the reading 210 degree. Now we will shift this instrument towards point B. Now we have shift this instrument from point B, from point A towards the point B. So again I will mark the center point of this point B, and I will check the point which will be exactly above the point B, and I will just fix this arrow above the point B. So to check the center point of our station B. Now I will measure the reading of point B. So for that one I will simply bisect the object. After bisecting the object, I will simply press this brake pin to measure the reading, and we will just note down the reading. So the reading for point C is 210 degree and 30 minutes. So we will just note down the reading, that will be 210 degree and 30 minutes. Now again we will bisect the point A and we will measure the reading of point A. So now I have bisected the point A. By pressing the brake pin, I will measure the reading at point A, and the reading of point A is 150 degree and 30 minutes. Now I will shift this instrument from this point B towards point C. So, I will just simply lift the instrument, I will carry the arrow with me and we will fix the ranging rod which is present at the station P, and we will fix that ranging rod at the point B. So, again approximately I have to manage the center point of the prismatic compass. So, you can see that you can adjust the tripod legs and you can fix the center point, and then you have to fix the arrow, and by using the plumb bob or by using the small drop of the stone, you can see that the center point is exactly above our prismatic compass. Now, again we will measure the reading of our point D. So, for point D, I will measure the reading. So, I will just bisect the point D. Again, I will press the brake pin and I will measure the reading. So, the reading for point D is 161 degree and 30 minutes. So, which we have recorded. Now, again we will bisect the point B. So, for bisecting the point B, I will just adjust my eyesight with my object side and we will note down the reading by using the brake P again. So, the reading for point B is 293 degree. So, I will just note down the reading, that is 293 degree. Students, now we have shipped this instrument at point D. So, we will measure the reading of point B and point E from the station point D. So, before taking the readings, we have fixed our center point with the help of plumb bob and with the help of arrow. So, you can check that the center point is exactly marked on the ground. After marking the center point, simply I will bisect my object without disturbing the tripod legs, and by bisecting the object, I will measure the reading, and my reading is 220 degree and 30 minutes for point D. And after taking the reading of point D, I will measure the reading of point E after taking the reading of point D. So, again I will bisect the object, and by bisecting the object I will measure the reading, and my reading is 345 degree. So, I will just note down the reading as 345 degree. So, now we have shipped our instrument at point E. After shifting the instrument at point E, I will bisect the point D. So, before starting the taking readings, you have to make sure that your center point is marked. So, my center point is exactly marked above the station point E. So, I will observe the reading for point D. Then after that observing the reading, I will press the brake pin and I will measure the reading. So, the reading for this point is 39 degree and 30 minutes. Then after taking this reading, I will taking the reading of our last point, that is point A. So, we will just simply bisect the point A by using the eyepiece and the object piece. I will press the brake pin and my reading is 300 degree and 30 minutes. So, guys, for prismatic compass the least count is 30 minutes. So, my all readings are ending with the point 30 minutes. So, now I have written down all these readings. So, we will just calculate what is our included angle for these points. Now, before calculation you can just see that, so in the surrounding area we are having some electricity poles, some vehicles are there, some disturbances are there. So, due to this local attraction we may have some errors into our readings. So, we have to check that errors and we have to calculate the errors and we have to distribute the errors before calculation of included angles.
So, students, these are some observations which we have made when we are performing the practical. So, as you know that we have taken 5 points on the ground by using the prismatic compass. We have observed 4 bearings and back bearings of that 5 lines by using the prismatic compass. So, same readings are written here. So, 4 bearing of each line and back bearing of each line. Now, to find out the included angle between these different lines, so we have to follow some steps. So, our first step while solving these problems, while finding the value of corrected included angle, is to find out the difference between 4 bearing and back bearing. Now, as you know that 4 bearing plus minus 180 will be your back bearing. So, this is the standard condition. Now, for this standard condition, we have to find out the differences between these two bearings, and whenever this difference is exceed by some amount, then we can call it as that station will be affected by local attraction. So, the magnetic needle is having the interference of the different things which are available in the nearby area. So, we have to take care of that things whenever we are doing this calculations. So, in first step, as I have said, that we have to find out the difference between these different angles. So, I will simply write here next column, that is of the difference. Now, you have to simply subtract this 4 bearing and back bearing. So, by using your calculators you have to solve these things. So, as by solving I will get the difference for the first line is 179 degree. So, again it is less than 180 degree. For second line we will get the difference as 182 degree and 30 minutes. For third line if you subtract, then you will get a difference of 180 degree and 30 minutes. For fourth line if you subtract these two value, then you will get a difference of 181 degree, and for the last line you will get a difference of 179 degree and 30 minutes. So, you have to take care of these things. Now, by observing these differences you can see that the difference between all the lines is not exactly the 180 degree. So, you have to find out the station which is least affected by the local attraction. Now, by observing these things I can see that this value 180 degree is 30 minutes is nearer to the 180 degree. So, we can say that either station C or either station D is least affected by the local attraction. So, for calculation result we will consider that this difference or this error we have to distribute amongst the forebearing and back bearing of this line. So, simply you have to write down that. Therefore, by observation, so difference between forebearing and back bearing of line CD is equal to 180 degree and 30 minutes. So, therefore, we can say that we have the error of 0 degree and 30 minutes. So, for finding the corrected bearings of this line, that is CD, we have to distribute this error evenly into both bearings. Now, you can see that difference is exceeding by 30 minutes. So, our error is plus 30 minutes. So, whenever you have to find out the corrected bearing, so you have to use the reverse sign of this error. Now, this error is plus 0 degree 30 minutes. Therefore, our correction will be minus 0 degree 30 minutes divided by 2. So, minus sign is used as we have the error value as positive. If we get the error as negative, then we have to use the positive sign instead of this negative sign. So, therefore, our correction will be minus 0 degree and 15 minutes. Now, you have to simply subtract this value of error from this 4 bearings. So, simply I will write here, therefore, corrected 4 bearing of CD will be equal to 161 degree 30 minutes minus 0 degree and 50 minutes. So, simply you will get the value as 161 degree and 15 minutes, and since similarly the corrected back bearing of CD will be equal to 342 degree 0 minutes minus 0 degree 15 minutes. So, your answer will be 342 degree and 45 minutes. So, these are our corrected observations for line CD. So, similarly, the corrected back bearing of this line CD will be 342 degree 0 minutes minus 0 degree 15 minutes. So, you will get 341 degree and 45 minutes. So, we can say that the corrected observations for line CD are are respect to these values. So now we know that the corrected bearings of fore bearing and back bearing of line CD are 161 degree 15 minutes and 341 degree 45 minutes. So if you observe the difference between these two bearings, so it will be equal to 180 degree. So now we know that this line is corrected and this one is having the corrected bearings. So it is our assumption that we have neglected the error. So our next step to finding the included angle is to draw a simple sketch or rough sketch of a polygon or of a different points which we have observed on the ground. So on the ground we have located these stations like this. So A, B, C, D and E. So these are the locations of all stations. Now in this polygon, in this closed traverse, I have to find out the included angles between these different points. So angle A, B, C, D and E, which we have to find out. So we will start with the angle A, B and C. So we will start from this point. So we will find out this angle first, then second, then third, fourth and fifth. So these are our included angles respectively. Now in this, so if I have to find out the included angle of A, B and C. So now for this point, so I will just draw a elaborative sketch. So this will be our point B. So for this point B, we have two different lines. So for these two different lines, we are having two types of bearing. So this one will be our back bearing of line AB. So this is our point A, this one is B and this one is C. So back bearing of AB and this will be your fore bearing of BC. So simply you can see that if you subtract these two angles, then you will get the included angle at this point B. And simple case to remember this thing is that, so simply you have to take a subtraction of this readings which are comes from different lines. So if you subtract these two readings, then you will get an angle B. If you subtract these two readings, then you will get an angle C. If you subtract these two readings, then you will get an angle D. And you have to remember one thing, if this angle by subtracting this is exceeds than 180 degree, then you have to simply subtract that angle by 360 degree, then that will be your interior angle. So these are some tricks to remember this type of subtraction and this type of calculations. So this is our elaborative figure of point B. So we will start with our calculation. Now the back bearing of line BC AB is 250 degree 30 minutes and fore bearing is 110 degree and 30 minutes. So I will simply write here. So angle ABC will be equal to 250 degree 30 minutes. So this will be your back bearing of AB minus 110 degree and 30 minutes. So this will be your fore bearing of line BC, and by subtracting this you will get the included angle. So by using your calculators you have to find out the included angle, and the value of included angle is 140 degree. So similarly for the next points we have to calculate the included angle. So for line BCD or angle BCD, if we have to find out this second included angle, then we have to take a difference of 293 degree 0 minutes minus 161 degree and 15 minutes. So you will get an angle BCD, and the value of your angle BCD by calculation we will get 131 degree and 45 minutes. Then for third angle, that is angle D, that is angle CDE, we have to subtract again the fore bearings and back bearing. So for CDE I will simply write 341 degree 45 minutes minus 220 degree 30 minutes, and I will get a angle CDE as 120 degree and 45 minutes. So this will be your included angle at D. Then for fourth one, that is angle DEA, again similarly we will calculate the difference between fore bearings and back bearing. So for this one simply we will subtract 300 degree 30 minutes minus 39 degree and 30 minutes, and then you will get a angle as 261 degree. Now this angle is greater than 180 degree. So you can see here this angle is greater than 180 degree. So this angle is your exterior angle. So for finding the included angle of this point, simply you have to subtract it from the 360 degree. So you will get 360 degree minus 261 degree, and your included angle will be 99 degree, which will be your included angle. So I will explain this thing into this figure. So in this figure you can simply observe that. So for point B we are having two types of bearings. So first bearing is your this, and second bearing, so we are having these two lines. So first bearing is the back bearing of this line, and then this will be your, this one is the back bearing and this one is the fore bearing. This is your point E, this will be A and this will be D. Now if I will subtract this angle and this angle, then what will we get? So we will get this angle only. So you can see that if we have to calculate this included angle, then for this one you can simply calculate the difference between four bearings and you have to subtract that difference from 360 degree, then that will be your included angle at E. So after finding this angle E, we will find out the included angle at point A. So again for angle EAB, we have to subtract the back bearing of line EA and fore bearing of line AB. So our difference will be 121 degree minus 71 degree and 30 minutes. So you will get answer 49 degree and 30 minutes. Now we know that the values of all included angles. So if we have to find out the sum of interior angles, then you know that we are using the formula for sum of included angles as 180 degree multiplied by n minus 2, and that will be your sum of included angles. So if this sum is equal to our calculations, then our problem is okay, and if it is not equal to our calculations, then we have some corrections in our calculations. So simply I will add the summation of all the angles which we have taken. So by adding these angles, I have observed that this sum is not equal to 540 degree, which is the sum of this polygon. So if polygon, we will consider the number of sides for this polygon are 5. So sum of included angles will be 180 multiplied by 5 minus 2. So 5 minus 2 is 3, 180 multiplied by 3, you will get a sum of included angles as 540 degree. And by observing this sum, we are concluding that this sum is not equal to the 540. So we can say that we are having some error in our calculations of included angles. So now as we have calculated the sum of interior angles and that sum is equal to 541 degree. So we know that we have to be calculated this value as 540 degree. So that is why we can say that the error for our calculation is 1 degree, and that will be also sign will be the positive degree, positive. So for distribution of this error, we have to distribute this 1 degree angle into the all sides or all angles of our polygon. Now the number of angles which we have calculated, included angles which we have calculated are 5 in numbers. So that is why I will distribute this error into the 5 angles. So as this 5 is the number of angles and this 1 degree is our error. So that is why we can say that we have to distribute this error amongst the all angles by 0 degree and 12 minutes, and the sign of distribution will be the negative sign. So similarly, by assuming this error, we have calculated this included angles. So the corrected angles will be for angle ABC, that is angle B, is equal to 140 degree minus 0 degree 12 minutes. So this will be our error. So the included angle will be 139 degree and 48 minutes. So similarly, we have calculated for this different angles also. So this will be angle C, D, E and A. So these are our included angles, corrected angles which we have calculated. So sum of these corrected angles, if we have we are adding all these angles, then we will get the sum as 540 degree. So in this way we can say that we have corrected our included angles. Now first we have corrected one line, that is line CD. then we have calculated the included angles, then we have corrected the included angles. Now the remaining part is what? So we have to correct the all bearings of different lines which we have calculated. For calculating this corrected bearings, we will take the help of this corrected included angles. So after finding the corrected included angles, so we will find out now the corrected bearings of different lines. Now we know that we have corrected the bearing of line CD. So the fore bearing of CD and back bearing of CD. So now we will start with line DE. You can start with line BC also, but we will start with the line D and E. So first I will write here calculation of corrected bearings. So our first line will be line DE. Now for line DE, if we have to find out the corrected fore bearing of this DE, then simply what we have to do. So if you do not understand what exactly the procedure, what will be the location of that point, then simply draw a figure of that different points. So now by drawing the figure, we will see that this D point is located here. Now for this point D, two values will be connected to this point D. So that will be the back bearing of CD and this included angle CD and E. So simply you can do one thing. So subtract this back bearing of CD and this included angle CDE, then you will get the back bearing of line, fore bearing of line DE. So it is written here already. So the back bearing of CD minus angle CDE. So I will write down the values of here. So the back bearing of CD will be 341 degree 45 minutes minus included angle of CDE, and included angle value we know that it is 120 degree and 33 minutes. So by subtracting these two values, we will get the fore bearing of line DE, and the value of fore bearing is 221 degree and 12 minutes. So this will be our corrected fore bearing of line DE. Now we will find out the corrected back bearing of this line DE. So now we know that the difference between fore bearing and back bearing is 180 degree. So this one is the corrected value. So if you subtract 180 from this one, then you will get the corrected back bearing of this line DE. So now simply I will write here 221 degree 12 minutes. Now if it is more than 180, then we will subtract 180. If it is less than 180, then we will add 180. So this value is less than 180 degree. So that's why I will subtract 180 sorry, it is more than 180 degree. So I will subtract 180 degree from this one, and then you will get the corrected back bearing of line DE. So after subtracting these two values, you will get the answer as 41 degree 12 minutes. So these two are the corrected bearings of lines. So I will do one thing, I will just change the values here. So for the next calculation, we will have the corrected values. So the corrected fore bearing will be 221 degree 12 minutes and corrected back bearing will be 41 degree and 12 minutes. So these are the corrected values. Now we will calculate for the line EA. So now for line EA, we will start with the fore bearing. So the fore bearing of this line EA will be equal to, now again this E point is located here. So for this E point, the related values are the back bearing of ED, that is back bearing of DE, and the included angle at point E. So now you can see that this DE is having back bearing of this value, and this will be your included angle. So if you will subtract these two values, then only you will get this value. But which answer we want? We want to find out the fore bearing of this line EA. Now we have calculated exterior and interior angle for this point. So the value of that exterior angle, so I will just write down here for your understanding. So the exterior angle at E, which we have calculated, is having the value of 259 degree and 48 minutes. So simply for calculation of this angle, we have to subtract 0 degree at 12 minutes, which is the error, and by taking this value, you have to find out the corrected back bearing of fore bearing of this line EA. So, for this corrected fore bearing of EA, I will just simply write here back bearing of DE plus exterior angle which is 259 degree and 48 minutes. So, by adding these two values you will get an answer of fore bearing of this line EA as 301 degree. So, here you can see that the value is 300 degree and 30 minutes. So, we will simply just rub this value and we will write down the corrected value as 301 degree. Now, if we have to find out the corrected value of this back bearing, then what you will do? So, you will simply subtract 180 from this value because this one is more than 180 degree. So, simply you can subtract 180 degree and you can write down the corrected value here, or I will just write down the step here. So, therefore, the corrected back bearing of this line EA will be equal to 301 degree minus 180 degree, and you will get the answer as 121 degree, and you can write down the answer here as 121 degree. So, this will be your corrected back bearing of line EA. Now, two lines are remaining. So, line AB and line BC. So, again now for line AB, so the fore bearing of this AB will be equal to again. Now, for fore bearing of AB, what we have to take? So, we have to take the back bearing of EA and the angle which is included by point A. So, now this will be our AB and we have to find out the corrected bearing. So, our first step will be the fore bearing of AB will be equal to the back bearing of EA, and we have to subtract the angle EAB. So, by putting the values you will get the answer as 71 degree and 42 minutes, and similarly the back bearing of this AB will be equal to, now this 71 degree 42 minutes is less than 180 degree. So, you have to add 180 degree in it. So, therefore, 71 degree 42 minutes plus 180 degree, and that will give you the answer, that is 251 degree and 42 minutes. So, these are the two corrected bearings of these two lines. Again we will just simply write down the values here. So, that is 71 degree and 42 minutes, and it is 251 degree and 42 minutes. So, these are the corrected values. Now, the last line which is remaining is line BC. So, similarly for line BC, the fore bearing of BC will be equal to back bearing of this AB, that is 251 degree 42 minutes minus included angle at the point B. So, the value of included angle at the point ABC you have to write down. So, that will be 139 degree and 48 minutes, and you will get the value of the corrected bearing as 111 degree and 54 minutes, and similarly the back bearing of this line will be equal to, the back bearing of BC will be equal to 1110 degree 54 minutes plus 180 degree. So, plus sign is used because this value is more than 180 degree. So, your corrected bearing will be 291 degree and 54 minutes. So, these are the corrected values of our bearing. So, simply we will write down here. So, it is 1110 degree 54 minutes, and the corrected value of back bearing is 291 degree and 54 minutes. Now, for your understanding, you can take a check of this point also. So, this line BC, so for CD you can take a check. So, you can simply subtract the angle CDE by this value of back bearing, and you will get again the answer as 161 degree and 50 minutes. So, in this way we have corrected all the values of bearing, we have find out the included angles by using the prismatic compass. So, in our results we have to write down that we have assumed that the station C and D are free from the local attractions, and due to this the readings which we have taken from these angles line CD are free from local attraction and are free from errors, and by observing this one we have calculated the included angles and we have calculated the corrected bearings. So, this prismatic compass is very useful whenever we have to find out the included angles between polygon or between the triangle, or we can say that in any type of closed towers we can use this prismatic compass.